Just a couple of skills that we'll need. We'll just need some basic algebra skills, and also the skill of solving proportions. So I'm going to show you a couple different ways to look at these direct variation, and I'm sure that you've seen a problem like this before, and you've studied proportional relationships in the past. But just want to give you a couple of methods, skills for you to help you with these direct variations. And you can kind of decide which way you want to attack. So we'll look at the warm-up to practice those. So number one, the value of a blank never changes. You can probably think about science for this too. In science, they call it something different. They call it the control. But the value of a constant or variable never changes. What do you think? So what never changes, a constant or a variable? Constant. Constant stays the same. What's the quote that they say? The only constant is change, right? Our lives are always changing. The only constant is change. But the value of a constant in math will never change. In science, it's called the control. Number two, solve 42 equals 6 times k. So that was a problem that we saw similar to yesterday. This is only a one-step problem. Our variable k, we're trying to isolate that. It's being multiplied by 6. We'll divide by 6, divide by 6. We'll get k is equal to 7. So k would equal 7 in that case. Lastly, number three, one of our methods we can use to solve direct variation is using proportions. So that proportion, we have 3 over x equals 4 over 12. To solve that, we can cross multiply and divide. 3 times 12 is going to equal 36. X times 4 would equal 4x. Solve that out, divide by 4 on both sides. X is going to equal 9. So a lot of times when we solve that one, we can just solve that mentally, possibly in our heads, or we can just use our calculator, but you're going to multiply your two numbers that are diagonal from each other and then divide by that remaining number. So 3 times 12 is 36. Divide by 4 would give me 9. So x equals 9. So what that does is what we're looking at is it makes 2 equal ratios. So 3 to 9 and 4 to 12 are going to be exactly equal to each other. All righty, let's head down then. Looking at the definition of a direct variation. So direct variation definition is where one variable, we'll call it y. Y is going to vary directly with x. Two formulas that we'll see today, y equals kx, and then the k equals y over x. And some keywords that tell us that it's a direct variation, we'll see varies directly, and you may see this directly proportional. In a direct variation, as my x variable starts to change, so x could represent maybe the amount of pounds of fruit that you want to buy. What fruit should you buy? What fruit should we buy at the grocery store? Apples. So x could represent your pounds of apples. As those pounds increase, what's going to happen to the cost of those apples? So as you buy more and more pounds of apples, what's going to happen to that price that you have to pay? It's going to increase as well. And that amount that it increases is directly related to how many pounds you buy. So as it increases, The pounds, the X, your Y, your price is going to increase at the same exact rate. So for me, I buy Honeycrisp. I know they're kind of expensive, but you guys ever had Honeycrisp apples before? And they seem like they never go bad. They sit in our fridge for like months, and you can still eat them. They're really good. They are a little expensive. They're probably like $5 a pound, something like that. So if I buy 1 pound of Honeycrisp, how much am I paying? $5. If I buy 2 pounds, how much am I paying? 10. If I buy 3 pounds, 15. So as I increase the pounds, X, 1, 2, 3, how is my Y increasing? It's going from 5 to 10 to 15. So how much is it increasing that? 5 pounds, or $5, excuse me. So as that X increases, it's directly related to the Y. That Y is going to increase at the exact same ratio throughout the situation. It's not like if I buy 4 pounds, now all of a sudden it's costing me $15 again. 4 pounds is going to cost me how much? 20. So it's going to be directly related. As I increase the amount of pounds, I'm going to also see an increase in my price at the exact same rate, 5 pounds for $5 at a time. Excuse me. The constant of variation is that price that we're talking about. So the constant of variation is what's called the K value. And to find K, you can take your Y over X. So K represents the constant. So that constant value that we're going to see in each case. So when you're at a grocery store and you buy anything by the pound, it's going to be a direct variation relationship. As that amount of pounds increases, your price is going to increase at that constant rate. So it's going to go up depending on how many pounds you buy. And a lot of things in the grocery store are sold by the pound. You think about any of the produce, vegetables, fruit sold by the pound, and then also you get into meat, proteins. Those are also usually sold by the pound. So those are all direct variation relationships. A couple other direct variation relationships. The circumference of a circle is a direct variation. So to represent that, we can use a direct variation equation. We can say the circumference equals a constant times the diameter. So C equals KD. So K is that constant. And that is a pretty popular formula. What does that K represent? What number is K? What's that irrational number that we use in that circumference formula?
Is it pi?
It's pi. So pi is that constant number. Anytime you take the circumference, divide it by the diameter, you get a constant. You get pi every time. Number 2, an electrician's formula, resistance is directly proportional to the length. So resistance, R, is directly proportional to the length. So the longer your wire is that you're putting in, the more resistance that wire is going to have. Number 3, the water produced varies directly as the amount of hydrogen burned. So water, we'll just use W equals K times H. Have any of you guys seen the movie or read the book called The Martian? You guys have seen the movie with Matt Damon where he's stuck on Mars for like 400 days? Seen it? That's what he does. What does he do with the jet fuel? Burns it, and then what does he make? What does he produce when he burns the jet fuel? Starts with a W. Water. Don't you remember that part? You don't? Where he burns it, then he's got this big like umbrella that catches all the stuff, and then the water condenses off of it, and that's how he makes water. Well, that's what he's doing. He's producing the water by burning the hydrogen. Because what's water made out of? Hydrogen and no chemists in here? You guys don't know what water is made out of? Hydrogen and what? Oxygen. Yeah, so he had oxygen in his little space capsule, hydrogen from the fuel, burned them together, produced water. So that's where that is. If you haven't seen the movie or read the book, Highly recommend it. It's great. Great story. It's fiction. There's nobody who's been to Mars, but it's a good story. All right, so we're going to take a look then how we can start to solve some of these direct variation problems, or they could also be called directly proportional. So when you see that proportional word, we're still talking about the same thing. So example 1, the number of teaspoons varies directly with the number of tablespoons. So here we see that word varies directly. This part in front, the number of teaspoons. Number of teaspoons I'm going to represent as my y variable. The number of tablespoons is going to be my x variable. Continuing, so now if I'm using 12 teaspoons, there's my y variable, is the same as using 4 tablespoons. So just recall that the constant is that y variable divided by x. So you take the price divided by the number of pounds of apples, that's going to give you that constant. Okay, that's going to be you take that circumference divided by the diameter, that's going to give you pi, gives you that constant. And then lastly, we say how many tablespoons is needed in a recipe of 6 teaspoons. So just to kind of keep track here, our y is representing our teaspoons, x is representing our tablespoons. So we've got this ratio, 12 teaspoons. 12 teaspoons is equal to 4 tablespoons. How many tablespoons are needed in a recipe calling for 6 teaspoons? We're going to write a proportion 6 over x. So if we know there's 12 teaspoons and 4 tablespoons are equal, then 6 teaspoons is going to equal how many? So we can set up a proportion for this. So when I set up that proportion, I can now do cross multiply and divide. I go 4 times 6 divided by 12. I'm going to get x is equal to 2. My final answer would be 2 tablespoons. Another thing we could do is we could figure out, well, how many teaspoons are in a tablespoon? If you're in culinary, you maybe study this. If you've been in it in the last couple of years, does anybody know how many teaspoons are in a tablespoon? There's 12 teaspoons and 4 tablespoons. How many teaspoons are in 1 tablespoon? It's 12 divided by 4. Great. So you've got 12 teaspoons is equal to 4 tablespoons. We can find the constant. This is like in the apple problem, we're trying to find that unit price, trying to find how many per pound. So K, you can take K is equal to y over x. So K is equal to 12 over 4, which is equal to 3. So our tablespoons y, excuse me, I said that backwards. Our teaspoons y is going to always equal 3 times the number of tablespoons. So that's another formula that we could use to figure out the number of tablespoons. Problem 2, we'll take a look at problem 2 as well. What is when an item of clothing is on sale with a percent discount, the sale price varies directly to the original price. So again, we are dealing with the direct variations. We see this varies directly. So the sale price is going to be my y. The original price is going to be my x. The shirt is normally priced at 30 and is on sale for 21. What is the sale price under the same discount structure of a shirt normally priced at 40? So again, we're going to say our y is equal to our sale. X is going to equal to our original. So we've got a sale price of 21 over 30 is going to equal a sale price of something over 40. So I'm just writing my proportion out in both sides of my ratios. I'm making sure I go sale price to original, sale price to original. So I got 21 over 30 equals blank over 40. And here we're going to probably want to use our calculator a little bit. So we would take 21 times 40 and then divide by 30. When we do that, we should get a sale price y is equal to $28. So there would be our sale price. And I'm not really going through the proportions because that should be something that we've seen before. So you can just take that, just took that 21 times 40, divided by 30, we're left with 20. The next thing we can do is we could find a constant. So if you want to do a proportion, that's all we have to do. You solve it out, great. But we could find the constant. Well, what is that constant sale price? Well, find the constant, I can take the sale price, 21, divided by 30. K is 21 divided by 30, which is 0.7. So my equation could be y equals 0.7 times x. Well, 0.7, what would 0.7 be as a percent? What would that be as a percent? 70%. So 70, I'm paying 70% of the original cost. Now stores don't tell you that, they subtract from 100 and tell you what that sale price is. So what this would be is, this would be a 30% off sale. So 30% off means that you're still paying 70%, 0.7 times that original amount, 0.7 times that. Okay, so that would be our equation that we could also use if we want to use the direct variation equation. Okay, number 3 is some more of the same. If you want to practice those on your own, you can, or want to fill those in later, but those are going to be exactly the same as these. We're going to finish up just looking at graphing a direct variation down at the bottom, number 4. So we've got speed compared to time. So an object falling in a vacuum is directly proportional to the time it has been falling. So that just means that if you drop an object, gravity starts to affect it, obviously, and it's going to start to increase speed according to gravity. Gravity falls at 9.8 meters per second. So we first need to find out what x is. So to find x, we can set up another proportion. So we can go 39.2 over 4 is going to equal x over 7. So we can start putting that in first, solving out for x. So I'm just taking those values, setting up a proportion, and we should get for x is about 68.6. So there would be our solution there. Part B, we're going to plot the 3 ordered pairs on a graph and then draw a line that consists of those 3 points. So we're just going to want to make sure for x, we know that x is now 68.6. So that's going to be our next data point. I'm going to head back to the graph. I'm now using 68.6. And since I don't have enough to count up to 68, over on this side, my scale I'm going to make is 10. And then this side, the time, I'm still going to use 1, 2, 3, 4, 5, all the way over. So we plot out our couple of points. So our first point was 2 and then 19.6. So I go over to 2. 19.6 would be just under 20. 4, 39.2 would be just under 40. Be right there. And then 6, 7. After 7 seconds, I was at 68. So let's just keep counting up here. At 7 seconds, I was at 68.6. We want to use this graph then to predict after 10 seconds. Okay, so if I draw my line, there it is. Okay, and then after 10 seconds, we want to predict where we would be. So that would be 80, 90, and 100 right there. So 10 seconds would be all the way at the end of the graph that I made, how I made it. So that would be right here, 10 seconds. And then going over to, kind of predicting, going over to here, about where it would be. It looks like it's a little bit under 100. Would be about where 10 seconds would be. But if I'm falling, the gravity goes down at 9.8 meters per second, 9.8 every second. What would 9.8 times 10 be? That's going to give you 98 meters. So after 10 seconds, that object would be falling at 98 meters per second. So graphing, we can also kind of see what the pattern is that's happening, and we can start to then predict where that's going to go beyond any of the data that we were given. So for the rest of the 15 minutes, we'll work on that worksheet. So you can work right in the worksheet digitally. That's what I would like you to do. So I'll just show you how that works real quick. We can even do that first one. So if you make a copy of that worksheet, you can just work right in it. So it says the number of inches varies directly with the number of feet. If a board measures 36 inches, it measures 3 feet. If a board measures 288, how many feet does it measure? So something that you can do on these worksheets is you can type if you want to type your answers. Or you can actually insert. If you go to insert, you can insert drawings. And then this tool here, you can select the scribble. Down here, and then you can set up and write out your problem. So we had 36 inches was equal to 3 feet, and we want to know 288 inches is equal to how many feet. So once we have that, we can cross multiply and divide. We'll take 288 times 3 divided by 36, and we would get x is equal to 24. And there it is. I can't get it to say equals there, but that'll work. And it'll just put your little drawing right into your problem. So if you could, I would appreciate for the worksheet, you can put that in there like so. Then if you're finished, you can just message it to me on Schoology. So you can just select it from your Google Drive after you make your copy, and you can just go ahead and message that to me in Schoology. That would be great. I'll come around and help with that if you need help with anything on the worksheet. But there's number 1. I'll leave that up there, and then we'll continue working on 2 through 5 to finish up today. So we got about 10 minutes left